So here's the lesson today. You can either print it out. I post a blank copy on Google Classroom, or you can listen to this video and then just do the homework. We are basically going to go through lesson 7.3 day 2, which is continuing on with this idea of similar triangles and talking about proportional sides as it pertains to having similar triangles. So from 7.3 day 1, we learned how to write those similarity statements. What we're going to do now is we are going to be able to find missing measurements using their ratios given certain parts. Okay, so here's what we're going to talk about specifically today. Today's going to be about when we have overlapping triangles, how do we find missing sides? And we're going to use this theorem that you guys haven't heard of before. It's called the triangle proportionality theorem. Okay, so here's what basically it says is if we have a line that is parallel to one of the triangles that intersects the other two sides, then it divides the two sides proportionally. Okay, so what we're saying is if we have these two lines are parallel to each other, so TU and QS are parallel, then here's what happens. Okay, is you're gonna have the first half up here is going to be RT. It's going to be proportional to, if you extend that line further to the end, it's going to be proportional to TQ, okay? So again, for this one, before we would have to take the length of a full line segment, now we just have to take the length of one line segment and then extend it to the end, okay? And that's going to be equal to that other side. So I'm going to start with RU, over the line extended US, We set those two parts equal to each other because they're moving at the same rate. And that's basically what the triangle proportionality theorem is stating, We can also go the other way. So when we're talking about the converse, we're talking about switching, so now what we're going to start off with is if you say RT over TQ is equal to RS over US, then we can say the two lines TU is parallel to QS. It goes both ways. So what we're going to be doing is we're going to be using both these theorems to help us find missing measurements or to confirm we have parallel sides. Alright, so let's look at a couple examples. So for number 1, it says find the length of QU. So what I'm going to start off with is QU is this length over here. What I'm going to do is I'm going to set up my proportion like this. If I don't know what QU is, you can label it as X and then just solve for that. So what I'm going to start off with is I'm going to start with that smaller triangle. On the left, I'm going to do 10 over that line extended is QU, so it's going to be 10 over X. And I'm going to set that equal to the other side, which is going to be 12 over 6. You don't have to add anything up. That's the nice part of this theorem. So how am I going to solve for X? Well, basically, there's a couple of options. One, you can cross multiply. So cross multiplying these two, you would do 10 times 6 is going to be 60. And then 12 times X is going to be 12X. Once you cross multiply, the fraction goes away. And so then finally just divide by 12, you get X is 5, or in other words, QU is 5, And that makes sense because if you look at your picture, here's a good check. 12, 6 is half than 12. If this is 5, 10 is half, or 5 is half of 10, So that would make sense going at the same rate, Let's try another one like this, So we're now just flipping the triangle a little bit. So now your two parallel lines are here and there, You need to find the length of KL, which is up here, So what I'm going to do is set up my proportion to solve for that, Here's what I'm going to start off with. If I start off with this 44, it's going to be over the line extended, which is going to be 24, And that's going to equal the other side. So the smaller part, X, over extended is 18. So then we just cross multiply and solve for X. So doing that, I'm going to do 24 times X, which is 24X. I'm going to do 44 times 18. When you plug that into your calculator, you're going to get 792. Oops, that's our. And then, so I'm going to divide by 24 to solve for X. You would get X is 33. And that would be the length of KL. So that's the first part, just figuring out the measurements. We're going to now switch it up a little bit. We're going to switch the two parts, and we're going to see whether or not we have parallel lines, okay? So let's look at a problem like that, okay? So here's what number 2 says. Part A, it says determine whether QT is parallel to RS, okay? So basically what you need to make sure when you're referring this is that the proportions are equal. Okay, so when I do that, what I'm going to do is this, okay, is I'm going to set up my proportion like I've done before, okay? I'm going to start off with, if I'm trying to determine these two lines, whether or not they're parallel, I'm going to start off with 18, okay, over the line extended is going to be 38. And I'm going to see if that's equal to 36 over the line extended is 80. Okay, and you can either plug this into your calculator and get a decimal, or you can just simplify it as a fraction. If I plug that into my calculator, I would do 18 divided by 38. Okay, don't round, it's going to be 0.47. Okay, and then I'm going to check to make sure that other side is equal. So 36 divided by 80 is going to be 0.45. Okay, oh, yeah, no, I'm good. Okay, and since those two are not equal, determine whether or not they are parallel. No, your answer is because those two parts are not equal. Okay. Okay. So that's like what we would see with parallel. Okay, let's do a similar one, but let's now label our parts. Okay, so what it says given AB is 31, so this is 31. Okay, BC is 19. Okay, CD is 27, okay, and then DE is going to be, 23, okay. We need to determine if BD is parallel to AE, okay. So, let's do it like this, okay. Is if we're looking at setting up our proportion, you can set certain proportions over each other. The problem with that is if you notice kind of this line right here, it doesn't meet at that vertex point, okay? So, automatically, since these are not like parallel triangles, that's a trapezoid, your answer would be no, okay? So if D doesn't meet at the vertex, your answer is automatically no, okay? All right, so that's with sides. We're now going to switch it up and talk about angles, okay? Specifically, we're going to talk about angle bisectors, which we've heard of before. Okay, so here's what we're going to talk about next, okay? I forgot what the name of this, okay? This is going to be when you have angles that bisect, or angle bisectors, okay? Okay. So for an angle bisector, here's what it says. It says if a ray bisects an angle of a triangle, then it divides the side into a segment whose lengths are proportional to the lengths of the other two sides, okay? So here's what I'm looking at, okay? Is if we're saying that this ray bisects that angle, okay, we're going to say this. If AD and BC, that's going to be equal to these two lines that the angle is bisecting, okay? So that would be AC on top and then BC on the bottom, okay? You could, if that proportion holds, then you have an angle bisector, okay? So let's try a couple like these, okay? So here's what it says. In the diagram, DEG and GEF are congruent because you have an angle bisector. Use the given lengths to find the length of DG. Okay, so here's what I'm going to start off with. Okay, remember, it's like these two parts are the bottom. That's going to be your first proportion. Okay. And then these two on the side is going to be your second proportion. Okay. We need to make sure we're setting it up in the correct order. So let's start on the left triangle. Okay, on the left triangle, if I was to set this up, I would start off with 5, okay, and then go to the right triangle. That's going to be over 15, okay. I need to set it equal to, starting with the left triangle, the side was x over 18, okay, and we're just finding the lengths. So doing that, I'm going to cross multiply. So 15 times x is 15x. And then 18 times 5 is going to give you 90. Okay. When I divide 15 by 90, you would get 6. Okay. So the length of DG is 6. Let's try one more like this, and then we'll be done with the notes. These are quick and easy. Okay, so looking at what I have, okay, here's the biggest thing. This is a little bit trickier, okay, but it's doable, okay. So what I'm going to start off with is if I know, okay, this whole thing is 14, okay, I need to somehow figure out this side here from G to F, okay. Well, the way I like to think of it is like this, okay, is if the whole thing is 14 and part of it is x, what I'm going to do with x, the value, is just subtract 14 from x. I'm going to replace that expression, 14 minus x, in with GF. Okay, so now what I know is I'm going to set my proportion, okay? So the bottom part is going to be set, so I'm going to start with the left triangle. It's going to be x over. The right triangle's bottom is 14 minus x. Think of it as just a number. Once I figure out x, I can find that out, okay? Okay, so then from there, I'm going to set it over those sides, 8 over 12, okay? Everything stays the same. You just have that 14 minus x in the place for a number, okay? What I'm going to do is cross multiply. So cross multiplying, I'm going to do 12 times x. That's 12x, okay? And then I'm going to do, this is where it changes a little bit, 8 times 14 minus x. What I'm going to do is I'm going to do 8, parenthesis, 14 minus x. That indicates that I'm going to multiply that 8 through, okay? So once I do that, it becomes an algebra problem. When you have that 8 out front, you're just going to distribute it in to both of those terms. So 8 times 14 is 112. And then 8 times negative x is negative 8x. Okay, equals 12x. Okay. From there, I'm solving for x. So I would add 8x to both sides, okay, first. And so you would get 20x equals 112. Okay. And then finally divide 112 by 20, you would get 5.6. Okay, so make sure you look back at what the question's asking. Okay, the question was asking you to find the length of DG. DG was at x, so in other words, DG is 5.6. Okay. So that's it for the notes, okay? I will post this key right now so you have it, and then the homework is the Delta Math, okay? Bye, guys.